At this point, you've learned quite a few C system calls. You've seen that some calls, like read or accept or even write, can block. In this video, we'll introduce a problem with using blocking read calls to read from multiple sources. Then we'll introduce a new system call that solves that problem by telling us which sources are ready for processing. Suppose we have a parent process that has forked a child. Before forking, the parent correctly set up a pipe from the child to the parent. Now the parent would like to read from the child. If the parent calls read on the child's pipe, and that child hasn't written anything to the pipe yet, then the read system call blocks. That means that the parent process doesn't go on to execute the next instruction, but sits and waits for the child to write something. When the child writes some bytes to the pipe, the read call returns. The parent checks the return value to determine that the read call succeeded. The parent goes on to execute the next instruction. In this case, it is another read call on the pipe. This read call will block until the child writes something. This time, the child closes its end of the pipe, and then the read returns and indicates the fact that the pipe is closed with a return value of 0. Got that? Read on a pipe blocks until there is something to read, or until the other end of the pipe is closed. Then, when there is action on the pipe, either to something to read or the pipe gets closed, read returns and the program continues. Now let's change the scenario to have two children with a shared parent where each child has a pipe to the parent. Our parent process would like to read from both children, or really from either child, whichever is ready. We need to have two different calls to read. One to read from child 1 and one to read from child 2. In fact, we probably want to have multiple read calls to each child, since children usually have a lot to say. Suppose we put them in this order. First read from child 1, then read from child 2. Then put the whole thing into a loop so that we can read lots. This works fine if child 1 is ready first, and every time child 1 writes, child 2 also writes. But what if child 2 has lots to say, and child 1 has nothing to say? The parent will block on the read from child 1 and wait, and wait, and wait. That's fine if child 2 didn't have anything to say either. But child 2 has lots and lots to say. So much, perhaps, that the pipe to the parent might get full. Then child 2's writes will block. Now both child 2 and the parent are blocked. Maybe it would be better if we reorganized the parent code to read first from child 2. Now the parent reads first from child 2 and then child 1. But as soon as one read to child 2 is complete, it is time to read from child 1 again, and we are back to the same problem. No matter how we order the read calls, we can always get into a situation where the parent is blocked waiting to read from one child while the other child has data ready to be read. Let's quickly walk through some code that illustrates this problem. The full version of this code is available in PCRS. I recommend you download it and play with it. We are going to fork two children. And each time we will check for errors and respond accordingly. Before we fork each child, we have to create a pipe and check for errors, of course. And here is where we declared the pipe file descriptors that we needed for the pipe calls. And like we learned in the pipe videos, we need to close the ends of the various pipes that we are not using. So all the code above here is to set up the situation where we have one parent with two children and one open pipe from each child to the parent. The situation from our earlier picture. Now we will read one time from child 1 and print out what we read. And then we will do the same thing for child 2. Make one read call and then print out what we read. Now let's add code to do something as the children. We close the reading end of the pipe, print a message to standard out with the child's PID so that we can see that the child is running, write "Hello, Dad" to the pipe, and finally close the pipe. Handle child 2 will be almost the same for now. We'll change the function name and change the message. Now, when we compile and run the code, we always read the message to Dad first. We don't know in which order the children actually ran, but we always make child 2 wait, and we read first from child 1. Let's add some code to child 1 to keep him busy for a while before he writes. In fact, let's keep him busy forever with an infinite loop, so he doesn't write anything to the pipe, but he doesn't close the pipe either. And before we finish editing, let's add one more line to child 2, just to confirm that this child has done the writing. We'll compile again and run. And we see that both children are executing, but the parent is waiting on child 1 to write something to the pipe. Child 2 has long since written the "Hi, Mom" message, but the parent isn't reading from child 2. This is a problem. No matter how we order the read calls, we can't be guaranteed to not be waiting for one child while the other child has data ready for us to read. In the next video, we will introduce the select system call. Select lets us specify a set of file descriptors, and then blocks until at least one of them is ready for attention. Then select tells us which file descriptors are ready, so we can avoid blocking on the non-ready ones.